This is the second note in Unit 4 on displaying data, specifically creating graphs by hand. So we're starting off with the second page of this note here because we're going to do the first page in one of our team meetings because we're collecting data from the class. So this is technically the second page, so you'll just have to flip over your note to start. So we're starting here with the histogram. So Tina would like to know the average number of hours her classmates spend watching TV during the week, so Monday to Friday. So right away, this is giving us a time period, right? So we should be able to kind of think back to our last note and determine what type of data this actually is. So this is going to be continuous, right? Because it's asking about a time frame, the specific time frame being during the week. So Tina has already collected the data. So we can see this is just like a little bit of a T-chart here, right? So our time intervals are an hour. So she gave them these options. So do you spend 0 to 5 hours watching TV, 6 to 10 hours, 11 to 15, 16 to 20, 21 to 25, or 26 to 30? And then, of course, we took tallies, right? So if we did this in class, I would ask you and I would put a tally beside each of these to figure out how many times. So the frequency is just how many people. So how many people watch TV for 0 to 5 hours? So the answer, we just count those tally marks, is 3. 1, 2, 3, 4, 5, 6, 7, 8, 5, 3, 2. Okay, and if we add all of those up, as long as I did this correctly and counted those correctly, we should get 25. Okay, and that means that everybody answered the question, so that's great. So let's actually use this data to create a histogram. So what's important here is that we need to label it fully. So first of all, we want to put a title on our graph. So what we're actually talking about is hours watching TV. So I'm going to say hours watching TV as my title. Okay, we can see that we have a scale going up the y-axis here. So that is going to represent the frequency. Okay, and the bottom is going to represent the number of hours. Okay, so remember that's your x, this is your y. Okay, so now we need to actually graph that data, right? So what we're going to do is we have to label each of our rows here with the number of hours. So the first one, and because this is a histogram, and the same thing with the bar graph, you don't have to have every single column labeled, right? So you might want to do every other. You might want to just skip the first one. It's completely up to you. Okay, I'm just going to skip the first one and start with 0 to 5. 6 to 10. This is really hard. I'm writing sideways here, so bear with me. 15 was the next category. 16 to 20. 21 to 25. And 26 to 30. And that is really messy, but hopefully you get the idea. Okay, and then because this is frequency, so it's not, well, I guess it does end up being the same as number of students. So we go up, we look at our data. Again, it's easier for you because you have it right in front of you. I have it on a page in front of me, so I'm just going to look at that. And we simply fill in kind of each bar to the level. So it was 3 people who watched from 0 to 5. So I just put a line there. I'm just going to go, I guess I can use the same color. 4 people watched 6 to 10. 8 people, and again, you would obviously use a ruler. And then we had 5 people, 3 people, and 2 people. And again, you could shade in those lines. Maybe you want to use different colors. Okay, and then I'm done now. I have graphed that data. Okay, so we can see from here, it makes it a little bit easier that most people watch 11 to 15 hours in this class, in Tina's class. So that's what we would write about our findings here, right? So most people in Tina's class watch 11 to 15 hours of TV a week. Awesome. Okay, so what is the difference between a bar graph and a histogram? And again, I'm not sure when you're watching this, if it's after we've done the first page, you saw that bar graph. If not, you'll just have to wait to kind of see that. But again, a bar graph is pretty basic. You probably understand what that means. So let's look at some differences between a bar graph and a histogram. So the first difference is going to be in the type of data we're collecting. Okay, so if we have a bar graph, that means we have categories given to us. So for example, like if we were talking about sports, the categories might be hockey, soccer, etc., right? So it actually gives us those categories. Okay, if we have a histogram, think about it as like history. Okay, so if it's a history, there's a time period, which means it's continuous. Okay, if it's continuous, that means our categories are always going to be intervals. Okay, and we saw that here, right? We had intervals, 0 to 5, 6 to 10. Those are all intervals. Okay, they're not categories, they're intervals. So that's the first difference. The second difference is how the graphs are drawn. How the graphs are drawn. So I'm just gonna change colors quicker here. So for a bar graph, there should be spaces between. Okay, so spaces between those categories. So for example, there's a space between there, right? They're not attached. Whereas if we have that histogram, there's no spaces. Because, and it makes sense, right? We don't want spaces because there's no spaces in our data, right? In our intervals. It goes from 0 to 5, and the next interval isn't 10 to 15, it's 6 to 10. So we have no spaces. And again, you can see that on the left, but it will look something like that. Okay, and just a reminder, continuous data is data that can hold any numerical value. So this is that, not first page, second page of the note, but first page we did together, and that is on the histogram. So we are going to look at a different type of graph, which has two names. So the circle graph or the pie chart, and likely you remember it as the pie chart. So it says, Sean is curious to know the number of people his classmates have in their family. The following data shows what Sean recorded in his notebook. Sean took this survey of his class and asked how many people are in your family. So this is quite the chart, right? So we have number of people. So he gave options, right? Do you have 2, 3, 4, 5, 6, 7, or 8 people in your family? And then, of course, he tallied, right? He would put a tally mark beside each of those when a person said they had that number in their family. So we are going to have to fill in the frequency. And again, the frequency is just how many tally marks there are. So I'll do that now. So there's 4, 10, 4, 2, none there, and 1 there. And again, if we add those up, 18, 20, that doesn't seem to be 24. Did I miss something? 18, 19, 20, 21. Okay, maybe the math is just wrong here. We'll call it 24. Okay, so this part is new. So it says percent. So round to 1 decimal place. So in order to find the percent, it tells us what we need to do. We need to take the frequency. Okay, so however many times. Oh, I didn't add that last 3. There's the 24. Okay. So we're taking the frequency, so how many times each category happened, divided by the total amount of people times 100. So for this next one, we would have 4 divided by 24 times 100. And again, you're going to do that on your calculator. You're going to get 16.7%. Okay, so 16.7% of the people in Sean's class have 3 people in their family. Okay, and then you just keep doing that same process. So if you do this here, 10 divided by 24 times 100 is 41.7%. Again, that 4 divided by 24, you're going to get the same percentage as the last one that was 4, so 16.7. 2 divided by 24 times 100 is 8.3. 0 is obviously going to be 0%, and 1 is 4.2% of people. Okay, and it's a percent because we're multiplying it by 100. As soon as we multiply by that 100, it becomes a percent. Okay, so the last thing that we need to look at for this pie chart is the measure of the angle in degrees. So because this is going to be a pie chart, it's going to represent a certain part of our circle. So we need to figure out, well, how large of a piece of my circle is this going to represent? So in order to figure that out, we have to take the frequency, okay, which is this column, which is just the number of people, divided by the total, okay, which is 24, times 360 degrees. So for this first one, we had 3 divided by 24 times 360. So we know that that section of our pie chart should be 45 degrees. Okay, so we're just going to keep doing with that same process. Again, you're obviously going to need your calculator here. So we have 4 divided by 24 times 360. Again, you're going to do that on your calculator, not in your head. You're going to get 60%. Okay, and you're just going to keep going with that same process. So 10 divided by 24 times 360 degrees is 150 degrees. Okay, and then you're just going to keep doing the same thing. 60 degrees, 30 degrees, 0 degrees, and 15 degrees. And if you add all of those values up, you should get 360 degrees. And the reason you should get 360 degrees is a circle has 360 degrees in it. Okay, so once we have the angle measurements, we can start to create our circle graph. Okay, and again, we want to label everything fully here. Okay, so we can see we have this line here. So obviously you would use your protractor if you have one to create these sections. Okay, that's how to truly go about these circle graphs. This is to use your protractor, which up until this point you probably were told just to kind of guess, but you're going to want to use that protractor. So I don't have one on me, so I'm just going to be estimating, but if you have your protractor, again, please use it. So the first category, I'm just going to start at the bottom and go up. So for 8 people, it was 15 degrees. So I know that's a pretty small angle. So I'm going to make it approximately like that, okay? And I need to label that 8 people. Okay, and I also want to say, okay, it's 8 people, but also this represents 4%. Okay, and that 4% comes from that percentage column above. Okay, so 4% of the class has 8 people. Okay, then, and I'm just going to keep going up. So the next one I'm going to do is 7. 7 is 0, so I'm not going to graph that. 6 people was 30 degrees, so it's going to be double the size of that one. I'm going to say it looks like that approximately. So that's going to be 6 people, and 6 people was 8%. Okay, for 5 people, it was a 60-degree angle. So again, it's double the size of that. So it's going to be like this. Oops. Approximately like that, right? Maybe a little bit bigger. And that was 5 people. Wow, that was messy. 5 people. And 5 people represented about 17% of the class. Okay, the next one is 4 people. So 4 people was 41.7%, which is a 150-degree angle. So it's going to be more than double that size, right? So I'm going to just estimate it's going to be approximately this big, right? It's not quite half, honestly, even a bit bigger. It's not quite half of your circle, but it's just about half. So I'm going to make it like that. Honestly, you could even make it a bit bigger because it's not a full half, so it's not this line coming straight across, but it's pretty dang close. So that is 4 people, which is 42% of the class. Okay, so now all I have left is 3 people and 2 people. So 3 people was 60 degrees, and 2 people was 45 degrees. So you can see now that I've come kind of into an error, right? Because I don't really have that much room left in my pie graph. So what I'm going to do is I'm just going to adjust this a little. I'll make this one a bit smaller. And then I need to represent 60 and 45. So one of them is going to be larger than the other. So this first is going to represent my 60, which is 3 people, which was 17%. So again, that one, these two here should look similar, and they do, so that's pretty good. And the last one was 45 degrees for 2 people, and that represented 12 or 13% of the total population. Okay, so now my pie chart here, my circle graph is complete, and it looks pretty good. So I'm going to write a statement about my findings. So specifically what sticks out to me here is that most people have 4 people in their family, right? So we would say in Sean's class, 42% of people have a family of 4. Okay, so that is the most common. And on the left here, you'll just see some helpful boxes. So in order to calculate our percent, we did frequency divided by the total times 100. In order to calculate degrees, it was frequency divided by total times 360. In order to label / color the different portions of the circle, a compass or a protractor must be used. Okay, so again, I didn't use one, but you should be using that protractor. And this is discrete data, right? So it's data that is distinct and can be counted. So for example, it was family members, or another example would be marks on a test. Okay, so this is the end of our note on graphing this data by hand.